All right, welcome back. Remember last time we said you could approximate the area under a curve, the graph of f from a to b, by breaking it up into intervals, x1, x2, so forth, where the last one was xn, however many you wanted. You grab the right-hand side of each rectangle, went up to the graph, and wrote down those rectangles, and then summed them up, and that approximated the area. And remember, the formula was that the area under f was approximately what we called r sub n, and r sub n was this formula, the sum from j equals 1 up to capital N, f of x sub j, delta x. You had to remember that the delta x was b minus a over n, and the x sub j's were just a plus j copies of your delta x. All right, so let's do an example here. Let's evaluate r sub 3 for the function f of x equals x squared on the interval 1 to, what did I want to do, to 2. Another way to say that is from a equals 1 to b is equal to 2. All right. So first of all, we need to calculate delta x here. The n is 3. The delta x will be the b minus a all over n, so that will be 2 minus 1 over 3, so that's 1/3. And then we need those intervals. Remember, the a sub j was just a, or x sub j. Sure, that's what I wrote up there. Good. X sub j is equal to a plus j copies of my delta x. So even though we don't need it, x0 will be a, x1 will be a plus 1 times delta x. So delta x is 1/3, so that's, so a was 1. So that's 1 plus 1/3, so that's 4/3. x2 will be a plus 2 delta x, so that's 1 plus 2/3. So we get 5/3, and x3, which has to end up being b, will be a plus 3 delta x. So that's 1 plus 3/3, which is indeed 2, as we knew it would be, because that's how we set it up. So then r sub 3, the right-hand rectangle approximation for the area under the curve, will be the sum from j equals 1 to 3, f of x sub j, delta x. All right, so this will just be f at x1, delta x, plus f of x2, delta x, plus f of x3, delta x, because that's what the summation notation means. First j is 1, plug it in and add, then it's 2, plug it in and add, and then it's 3. All right, we figured out what these were. X1 was 4/3. If you plug it into f, which was the square function, you get that. Your delta x was a 1/3. And then you plug in x2, that was 5/3. So you square it and multiply by 1/3. And then you plug in x3, which was 2. You square it and times 1/3. And that's the answer. You can, of course, simplify it, but who cares in this case? All right, that's it. See ya.